Okay, hi, Assalamualaikum and very good morning. So today I will present about my assignment, which is the title of my assignment is Voltammetric Determination of Active Pharmaceutical Ingredients Using Screen Printed Electrodes. So before I continue my presentation, let me introduce myself, which is my name is Fatimah Syazwina binti Maslan, and my matrix number is SA22063, and this is assignment from subject Electrochemistry, PSK 3583. So let's continue our presentation, which is the first content is background of the work. So my title of voltammetric determination of active pharmaceutical ingredient using screen printed electrode because of the increasing consumption of pharmaceutical products worldwide has led to growing environmental concern. This is because due to the release of active pharmaceutical ingredients, which is the short synonym is API, which is the environmental concern due to the release of API into water bodies, and then these residues stemming from manufacturing waste, improper disposal, and excretion have been detected in various water, such as um, including drinking water and groundwater, even at trace levels. Traditional analytical methods used such as HPLC and GCMS. Because HPLC and GCMS offer high sensitivity and specificity. However, they are costly, require trained personnel, generate chemical waste, and impractical for on-site or rapid detection. That's why Voltamery offers high sensitivity, low cost, portability, and minimal simple preparation. That's why screen printed electrodes, or the short synonym is SPE, are particularly advantageous because it is disposability, miniaturization, reproducibility, and ability to be mass produced. Next, we go to the problem statement, which is despite the promise of voltammetric techniques and SPE, most reported studies that there are some problem statement and some of it is focused on the detection of only one or two analytes at a time. The second one is often employ conventional laboratory electrodes rather than SPEs. And the last but not least is lack demonstration of their application in real world complex matrices. There is a critical gap in developing a rapid, reliable, and simultaneous voltammetric method for detecting multiple API using commercially available SPE that can be applied in routine environmental monitoring or quality control setting. So next, we move on to the methodology. So the author of this scientific research developed a voltammetric method using differential pulse voltammetry, or we call it as DPV, on commercial screen printed carbon electrode, or the short synonym is SPCE. The methodology include five steps, which is the first one is electrode platform, which is unmodified SPCEs with a three electrode configuration, which are carbon working, carbon counter, and argentum or argentum chloride reference. Then the second one is electrolyte and pH optimization, which is acetic acid or acetic buffer was selected with pH optimized at 5.0. And then the third one is target analytes, which is for commonly used API, which is active pharmaceutical ingredient, which is sorbic acid, for paracetamol, dextromethorphan, and last but not least, caffeine. And then to the next step is DPV parameters, which is have three parameters, which is potential window, which is at negative 0.5 volt to positive 1.6 volt, and the next is step potential, which is 5 MV, and then last but not least modulation amplitude, which is zero point 0.1 volt, and the last step in this methodology is validation, which is conducted in a commercial cold medication and spike well water samples and quantification by standard addition method to account for metric effects. So the method allows for simultaneous determination of all four analytes in a single run with a minimal sample preparation. So here we go to the result and discussion. So this is the result first. So we can see here from our four API, which is ingredients, active pharmaceutical ingredients, which is ascorbic acid, paracetamol, dextromethorphan, and caffeine. So based on this linear range, we can see it. All of these API have different linear range and detection of limit. So we move on to the discussion, which is the DPV analysis provided well-defined oxidation peaks for each compound. So we can see it for all of the APIs and the recovery and precision. So the recovery values, it is from 99.5% until 100% in pharmaceutical and water samples. Next, for relative standard deviation, it is less than 5%, which is indicating excellent repeatability. These results validate the proposed method's sensitivity, accuracy, and robustness, making it suitable for screening multiple APIs in diverse samples. Last but not least, we go to the last point, which is conclusion. So, the study successfully demonstrated the potential of commercial SPCES combined with DPV for a simultaneous, accurate, and rapid determination of four pharmaceutical compounds. So, the key takeaways is the first one is the method is cost effective, reproducible, and environmentally friendly, aligning with green analytical chemistry principles. And the second one is it offers a suitable pre-screening tool before advanced chromatographic analysis. And last but not least is the disposable nature of SPEs eliminate cross-contamination risk and simplifies operation, making it ideal for on-site analysis and resource-limited setting. So this work pave the way for further developments in portable pharmaceutical sensing and environmental monitoring using voltammetry. So here are some references, which is the author for the scientific researches. That's all. Thank you so much.